Gentlemen,
Because these are vague topics.
I truly believe that the new frontier and the true new frontier is going to be component material. From now on, more than geometry or even surgical technique, it is the material of the components which will decide the long-term results in arthroplasty. The other two areas, as I just mentioned, have reached a peak or a plateau. Hence, it is important that all arthroplasty surgeons have a basic understanding of biomaterials forming joint components. And today, I will be speaking on the polyethylene as a material. And we all know that polywear and its sequelae are important contributors of failure in knee replacement surgery, and especially so as patients are becoming younger and more demanding. And more than 50% of the failures that we see is related in one or the other way to poly failure. And what is poly? It's the most common plastic, with around 80 million tons being produced annually. Many kinds of polyethylene are known: low density, linear low density, high density, and ultra high molecular weight polyethylene. For our interest, the last one is where we have our focus on, and from now on I will be using the word poly just for sake of brevity and not to repeat the ultra high molecular weight all the time again. It's interesting to know that polyethylene was first synthesized as an accident by a German chemist as long back as in 1898. And even the first industrial process of manufacturing poly on an industrial scale was an accident. This was at the Imperial Chemical Works in Britain. So what are the factors affecting the poly behavior in our arthroplastic components? One, grade of resin, manufacturing process of the base material, and manufacturing process of the implant. Let's look at the grade. Various grades of poly resins have been available for orthopedic implant application, primarily from one company. Today, almost all manufacturers source their poly from this one company called Ticona, which is now called Ticona. And the commonly used resins in orthopedic implants are GUR 1050 and GUR 1020. The words the GUR come from granular ultra high molecular weight Ruhr Chemie, which was the name of the company, GUR. Let's understand what these numbers mean. The numbers following GUR refer to the first digit. 1 represents the loose density. The second digit, if it's 0 or 1, it will indicate whether there is presence of calcium stearate, which is used as a lubricant to assist the processing of poly powder. The third digit, whether it is 5 or 2, refers to the molecular weight, and the fourth digit refers to the resin grade. The ultra-high molecular poly is produced as a powder and must be consolidated under elevated temperatures and pressures. It is produced by either compression molding or ram extrusion. What does it mean? Compression molding, it's a powder. A huge amount of compression is generated on this powder under various temperatures and pressure, and the final shape it comes out of the mold. Whereas in ram extrusion, the same thing happens, but instead of getting the final shape, the powder is pushed through a small tunnel, and it comes out in the form of a cylinder, and that cylinder is then later on machined into the final shape that you want. The process of consolidation requires a proper combination of temperature, pressure, and time, and the precise combination of these variables are proprietary secrets and have a significant effect on the final performance of the product. For example, here you see 3 grades: GUR 4150, GUR 1120, these were historical, and GUR 1020. All it means is that the use of calcium stearate in the early processes were associated with fusion defects, and therefore calcium stearate is no longer added to orthopedic grade polys. The manufacturing process of the implant is extremely important, and these are the 5 basic steps no matter which company's implant you choose. Choose the resin, which normally is 1020 or 1050. Irradiate to cross-link it, which releases free radicals, and we'll talk about it in a moment. Then stabilize it to remove the free radicals, machine it into shape, and finally sterilize it. So let's start this. Poly is irradiated either by gamma radiation or electron beams, and it induces cross-linking, which we'll see is a benefit, but it also causes the generation of free radicals. And what happens? 3 things can happen when you have a free radical. It can recombine with hydrogen without changing the structure of the molecule, and that's a neutral impact. it can bind to another free radical to form a cross-link with another poly molecule. It increases cross-linking and enhances wear resistance. This is a positive impact. And it can bind in with an oxygen atom and cleave the molecular chain. This causes oxidative degradation, and this is a negative impact. The first 85% of the benefit, 85 to 90% of cross-linking is when you expose the poly to 5 megarad of radiation. Another 5 megarad of radiation will increase the wear resistance by 90 to 95%. The problem is that whilst the wear rate drops dramatically up to 10 megarads, other properties are also affected. For example, the elongation, fracture fatigue, and toughness. So in other words, there is a mechanical versus behavioral sort of wear resistance trade-off here. The increase in wear resistance is also associated with a decrease in the mechanical properties of your poly. In other words, this is the one-line message. The poly becomes harder and therefore resistant to wear when you increase the cross-linking, but it also becomes brittle and therefore vulnerable to fracture as the wear resistance increases. The other devil introduced by free radicals is oxidation, and this can occur in vitro in the form of the free radicals reacting with the oxygen present in the air or in the packing, and therefore most of the time it's vacuum packing that is done now, or in vivo. Once you put the poly in the human body, the oxygen within the human tissues and fluids can react with it. So oxidative stability is very important, and therefore this stabilization is achieved by doing thermal processes. And there are 2 thermal processes. One is remelting, which means melting it above the melt point of poly. This removes all free radicals and makes it highly stable oxidatively. But once again, it causes some additional loss of mechanical strength. The other method is called annealing. Annealing is when you raise the temperature but keep it just below the melting point, you make the poly into a doughy substance. This takes away free radicals, but not all of them. So whilst it improves the oxidative stability, it protects the reduction from mechanical strength. And lastly, you have this additive of antioxidants these days, like vitamin E, which is an alternative to the thermal processes. So in other words, ideal poly is a trade-off. Finally, you machine it into the shape that you require and finally sterilize it, and this time with either low dose of gamma radiation or with gas plasma or ETO. So key things to remember: choose the resin 1020 or 1050, irradiate to increase the cross-link. This will cause oxidative instability. So you stabilize it either by remelting or by annealing. You add an antioxidant as an alternative or an additional step to the stabilization process, and finally you machine to shape and sterilize. In summary, yesterday it was historical RCH high density poly which Charnley used. Then came the GUR 1120 type of materials where there was calcium stearate. Gamma radiation was done up to 4 megarad. The calcium stearate was used as a lubricant. Today you have 1020 or 1050 only. The calcium stearate is no longer used. Gamma or electron beam radiation is used for cross-linking. Thermal treatment is added for stabilization, and final sterilization is done by gamma or ETO. And tomorrow, vacuum packaging is done. And tomorrow, the antioxidant is the new field of adding, and you have the improvement in material grades. In summary, the ideal poly is a balance. Cross-link poly, all companies manufacture. This is a chart of all the different options available, and this is where the vitamin E is coming into the market. All manufacturers are coming in with their own versions of vitamin E added all polys. Thank you for your attention.